That's also why now they're moving to entropic gravity, if you haven't noticed. Let's see what they can say about entropic gravity. This is quite cool. I like Erik Verlinde. Gravity does not exist. Ooh, here's another gravity does not exist. But this is simply what Erik Verlinde said, because he's now going against... Obviously, he's not saying gravity does not exist, as he says. He believes gravity, but he's saying, how can I put this, that gravity is entropic in nature. So now they're pushing entropic gravity. It's been quite a while that they started pushing this, and it looks to be coming more and more into the equation now, which is really odd. If you guys say gravity is a proven thing, you say it's fact, it's scientifically. Okay, let's get this going. What you gonna say, Verlinde?
I mean, gravity, of course, is something that well, many people have already thought about it.
Yeah, so much people have thought about gravity. Remember, he's a theoretical physicist. That already says weird stuff, don't you think?
Something that we see every day, and it's not like it's not existent in our every life. But
no, gravity is definitely non-existent in our everyday life. We have what you guys call gravity because things falling, which is simply just relative density disequilibrium. Things are denser, therefore the air around it cannot support it. But yeah, let's listen what it has to say.
What I mean by that it's an illusion is that one would eventually like to know where it comes from.
Huh. But you guys would have to know where it comes from if you're actually saying it's, what can I say? Didn't Einstein say it's from the bending of space and time? So therefore you've already said where it comes from. And Newtonian said it's because mass attracts mass. So, really weird.
An explanation. Up to now we have, well, descriptions. I mean, Newton, of course, is
Newton described it as mass attracting mass, as a force.
The one famous for first writing down a theory of gravity.
Yeah, the theory, you guys heard that. So we can say it's a colloquial theory because it's not scientific. What was the IV in the scientific method to present gravity in the first place? There wasn't one.
And he could describe why apples fall and why the moon...
Yeah, describe, you get that, guys. He can describe why it falls. We can also describe why it falls, and we can actually prove it scientific. Remember Anthony's egg experiment. He actually manipulated the IV to get the DV. This was just a description. He didn't manipulate anything. He just said, gravity, therefore, apple fall.
Goes around the Earth using the same basic equation for gravity.
You see, guys, I thought maths is not science, but he's using equations to base reality off of. Remember, math doesn't prove things.
But he described it. He had to assume that gravity was there.
Had to assume gravity was there, exactly. He had a belief that it was there. Very simple.
And then had to write down.
Then had to write. Yep. I still find it odd that he didn't want to be ascribed to this spooky action at a distance rubbish. Sorry, it's busy loading up now. Oh yeah. Come on.
Down a law that described that when two masses are at a certain distance, how they attract each other.
Yeah. You see? So he had a belief, then he made a description based on that belief, create equations, because his belief is that there's a law that creates two objects from some different masses to attract one another. No, that's not biased at all. Very scientific.
But he was also not very happy with the fact that he should just assume that these things, these objects...
he's not happy with it at all. That's why he
attract each other and without even anything in between. So
you know what's odd about this though? If you're not happy about something, let's say you're going to create a so-called scientific theory, and you're not happy with it, are you going to present it to anybody? I wouldn't present it to anybody because I want to be happy with it before I present anything. Because I'm going to know, listen, yeah, there's a doubt that it's not true, so therefore I won't present it. That's kind of goes against what science is, don't you think?
So if there are two masses in empty space, there's no...
You heard that. There's two masses in empty space, then there's no... we'll see what he's going to say about this. See, I did actually like this. Yeah, I used this in one of my videos a while back. Thank you, Erik Verlinde. Yes,
nothing that really happens between them, but still they're...
See, nothing really happens between them, but still there's an attraction. How can something that's not happening cause something to happen? You know, you can't have something physical happen without something not happening. This is what your gravity is based on, having an acceleration that is not physical. Show me acceleration that's not based on physical reality. You need physicality to have acceleration. That's how physics works in real life.
Attracting each other, and he thought that was kind of mysterious, and that it was something...
It wasn't mysterious, it's supposed to be wrong. If you thought something that goes against natural physics, it's not mean it's mysterious, it just means it's wrong.
He would have liked to explain in a better way. So later came Einstein, and Einstein with his theory of relativity.
Yeah, this is because Einstein came on because they couldn't have anything for... Because remember, Newtonian was shown wrong, so now they need someone to fix Newton's blunders because it's based on belief. So therefore comes Einstein and trying to say, well, you know, because you can't actually explain why it's happening, let me try and explain to you, based on maths, in a dimension that doesn't exist, so we can try and get it to work.
Eventually realized that also gravity has to be described in a different way.
Yeah, he realized it has to be described in a different way. I wonder why.
And it took him quite some years, but then eventually he wrote down a theory where he thought...
He wrote down a theory after a few years?
About space and time together.
Okay. This theory, space and time. First of all, space is just nothing. It's just space. It's available space. It's not physical. Time is also just nothing. It's a man-made construct which you base a reference on a timeline, so you have a reference to know something. So you can have a duration or something because it's a reference. It doesn't literally exist. You can't manipulate it. You can't do anything about it. So how can you have something that's non-existent because, and something that's a man-made construct actually doing something together in a dimension that doesn't exist in reality?
And then his explanation of what gravity would be is that there's masses which curve.
There's masses which curve. Yeah, masses which curve. It's kind of, if you had to have a woman, you'd kind of think you've been kind of sexist, don't you think?
Space and time, and then the motion of planets and of...
You see what I'm saying? If you just listen to how he's saying it, there's so much belief placed into what's going on. He's had already a bias decision from the start, even though he can't explain why it happens, Newton, but it has to happen, so he's not happy with it, but he's going to present it anyway. Then they come and have another guy, Einstein, making the glue for it because they couldn't be explained, but still based on a belief on creating it. So that's what I'm saying. They keep on having to make new stories up to replace something because it is not, in the first instance, real. You're making up a story based on belief on something you think reality works, but it doesn't. That's why you keep changing it. That's why it's not science. That's why it's seen pseudoscience, and that's why it's never ever been scientifically validated. That's why when you ask someone today, what is gravity? They cannot tell you what is gravity. They can't. There's no such thing as gravity. From the fundamental basis of when it started to where we are now, it changes because gravity doesn't exist. It's based on a mathematical belief system of a model that needs it.
The Earth around the Moon, or the Moon around the Earth, is then described by thinking about moving in this curved space-time.
Yeah, moving in, let's say, moving in nothing, guys. He's moving in nothing. So he's curving nothing in a fourth dimension in a man-made concept to get his gravity.
And how then objects are making their orbits.
Orbits. I still haven't got from FTFE how orbit is scientifically validated, guys. Remember, I asked him a very simple question. What is an orbit? How do you scientifically validate it? And he was trying to reverse the burden of proof onto me. So yeah, if you haven't watched that debate yet, do go. It is on my channel. Shame.
And the reason they go around then in circles is that that space and time itself is curved in the sense.
How is something that's a space, there's nothing there, curved, it doesn't have a shape? And how is a man-made construct, time, that's also not physical, curve?
Sense that things don't move in straight lines anymore, they go around. So that was his explanation, but he had to write down equation for it.
Yeah, he had to write down an equation for it to describe his belief system, exactly.
Which again assumed that gravity is there, because he basically wrote down that the matter curves the space-time.
Yeah, exactly. Curve in space-time.
So in a certain way, that's still a description, or what I should say is, well, one would like to understand again why this description sort of...
why there's a description. Yeah, he's got a description. Why? Because it's based on a belief, and he has to fix the blunders of Newton, and now you guys have to fix Einsteinian gravity, because that's also shown false now too.
Well, how you can understand it from a more basic point of view. So what I've done in my paper is try to start from a from a point of view where you
start from. Remember, he's starting from a point of view on his paper, guys.
Don't assume gravity to be there.
Don't assume gravity to be there. That's a great start. Okay.
Would like to explain it by seeing how you can derive it from a more microscopic set of equations where gravity.
No. I understand you want to make it from assuming it's not there. That's 100%. That's good, because it isn't there. But then when you want to have to derive it from equations, you're not doing science, you're doing math. You're taking reification belief and just trying to reify it into reality once again. Therefore, it's not real.
Gravity itself is not assumed, but then just follows from a certain logical reasoning.
Okay, logical reason, guys. He thinks it's logical reason. How should we think about the forces that exist to create the illusion of gravity? But remember, gravity is not seen as a force, so how do you have it if it's not seen as a force?
Very tiny particles. And it turns out that things like positions and velocities are not very precisely defined.
Oh, they're not very precisely defined. I thought the heliocentric model is very, how can I put it, accurate to the millisecond and stuff. So it's not precisely defined, guys. Really odd that one of your leading theoretical, I keep getting theoretical, physicist is saying it's not precisely defined.
You have to take into account the fact that there's an uncertainty in
the uncertainty principle. Yes, there's a reason why that's there, because it doesn't exist, remember?
Look at something, we may influence the measurement, but we may also just...
so you may influence the measurement. So because you actually admitting you may influence the measurement means it's not science, therefore it means it has a bias. Therefore it's pseudoscience, guys.
A fundamental limit on how...
yes. You can see the clock's turning in his head trying to figure out how to make this work.
Precise, you can understand the position or the velocity of a particle. They cannot be not both described infinitely precise.
Yeah, they cannot be described precise, exactly, because it's based on a belief model.
So taking gravity into account then gives us a bit of a problem, because then we have to talk about space-time, and then these quantum uncertainties gives us another way of looking at.
Yeah, very understand. Flat for life. Everything you thought you knew about gravity is wrong. 100% agree. What did the Washington Post say? We're going to get onto that now. Let's first, thank you for that, dude, really appreciate it. I didn't miss any super chats, did I? I don't think so. Okay. Again, thank you all for being here. Please just hit the like button and share button. Let's get it going to the people. So let's get on.
At space-time at the short distances. So this led to problems, and string theory is another.
String theory, oh. The name says it all, string theory, guys.
A way of also looking at gravity and quantum mechanics.
Yeah, quantum mechanics, the thing that...
which I've been working on quite a bit.
Quantum mechanics.
So people have studied...
Quantum mechanics, the thing that does debunk relative... GR at the moment. I see it, that's what's perspective. The cogs are turning, yeah. Exactly, Tony. There are literally no... there's issues, and they have to try and get around these issues.
The problem of quantum mechanics and gravity from various perspectives, from string theory, but also by thinking, for instance, about black holes, what happens.
Oh, black holes, yeah. Remember, black holes have to come into it, definitely. Hopefully it's going to bring up some quantum foam here, because that's going to be quite cool.
With black holes. And I've taken some of the things we've learned about it and seen that there is some explanation of maybe where gravity then comes from.
Okay, so you don't actually know where gravity comes from, you're just making assumptions on what you think where it can come from. Okay.
From those new way of thinking about quantum mechanics and gravity.
Yeah, exactly.
So if you then start trying to explain where it comes from, it has to do with the fact that there's
okay, sorry guys that I still have to keep pausing it, but we don't want any copyright strikes, because I get a lot of trolls in here that like to report me for some odd reason.
Microscopic scale, a certain information about how you describe this, which we don't see ourselves.
We don't see ourselves.
We forget about that.
Yeah.
And it turns...
we don't see it ourselves, guys, but we can say it's there, but we don't see it ourselves. Remember
that if you...
It's faith-based.
Take that into account in some appropriate way, that you can understand where gravity comes from.
Okay, where gravity comes from, okay. When other people talk about gravity, what are they describing? Obviously, you don't have to read or all that. I want to see where he says gravity is not real. Does your research have any implications for our daily lives? This is quite a good one. Let's see what he says. Quantum foam is ether. The quantum foam ether. Yeah, Lappy. I wouldn't be surprised if they're going to start lumping that together.
It's fun to think about things like gravity and even, well, what I had in my paper, things like even the laws of Newton, because...
Okay, it's fun to think about it. Let's see why.
They do play a role in one's everyday life. But it's surprising that...
Where do they play a role in one's everyday life? I know relative density plays a role because things are denser and it cannot support it. But I don't see gravity playing any role. Just because you guys call it gravity doesn't mean it plays a role. You guys don't even know how to define it. You don't know what it is. And you can't scientifically validate it. And it's based on a belief.
When I go and walk out the door or something like that, it's not like I immediately sort of think about these things in a different way.
Yeah.
But
yes, okay.
For me, I think it's more important eventually what will be the implications for understanding not just gravity, but also what's happening in...
How can you understand gravity if you don't even know what it is? That's kind of a contradictory claim, don't you think? Understanding something you don't even know what it is.
The universe, I mean, the gravity equations of Einstein are also used in describing the expansion of the universe.
Using it for expanding more belief. Expansion of the universe is based on belief. Remember, everything you guys are basing your model on is based on equations describing based on a belief.
Big Bang theory.
The Big Bang theory, which defies all logic and thermodynamic processes,
are all based on these same equations.
Yeah, all based on these same equations, proving that it is not reality. Math is debunked, remember? like when I had the ice pack or the cup for everybody to know. Do go and watch that debate against me and FTFE where I explained to him why math is not reality and proven.
What I hope is that the ideas that we are now starting to develop for gravity can eventually sort of lead to possibly somewhat better or even more refined way.
Measure it at your own risk. At the end of the day, all you guys are doing is looking at the explanation for reality and calling the explanation wrong. The reality is still that the Earth is a sphere, is space. First of all, write a coherent sentence. Second of all, no. Gravity, you can't even describe gravity. You don't know what it is. And we can scientifically validate relative density disequilibrium. We can literally do an hypothesis, an experiment. We can physically describe it. We can show it to you. Gravity keeps changing and placed in man-made concepts that cannot be observed. Yeah, not reality. Sorry, man. Hey, Uncommon Sense, good to see you. Glad you could make it.
Thinking about the early universe, and I think that will influence a little bit more my thinking than.
Yeah. Sorry, guys.
Yeah, I think as human beings we like to know where we come from, and
yeah, we like to know where we come from. But as you guys said, gravity doesn't exist. Really awesome. Okay, let's see what this says. No, I don't need to get any weeks free. This is from the Washington Post. Thanks, dude, for giving this to us. Everything you thought you knew about gravity is wrong. What you think you know is a series of illusions. Kind of telling, you know, like a magic show does with illusions. Perspective by Richard Panik. Richard Panik is a Guggenheim Fellow in Science Writing and an author in The Trouble with Gravity, Solving the Mystery Beneath Our Feet. Okay. Don't you just love this photograph, guys? Yeah. Okay, we don't know what gravity is. There we go, guys. Game over. We can just go home now. It's over. We don't know what gravity is. Say that to an average person, and the answer you'll probably get is some version of, what are you talking about? Gravity is the force of attraction that makes things fall straight down. Obviously, that's people that don't actually know what gravity is because that's what they do. They just parrot what they learned. But says it to a physicist, and the answer you'll get is, that's right. Kind of a contradictory statement there, because it's not right. So a physicist is supposed to tell you, no, sorry, gravity is not a force, so it's not a force of attraction because there's no force. Anyway, I know because there are two answers I've been getting for the last few years, ever since I figured out that nobody knows what gravity is. And that just about nobody knows that nobody knows what gravity is. Also true, because nobody knows what it is because it doesn't exist. It would exist. You would know what it is if it did exist. The exception is physicists. They know that nobody knows what gravity is because they know that they don't know what gravity is. Wow. The assumption that they do, that we all do, is understandable. Unless you think hard about gravity, your brain does what it evolved to do. Oh man, evolution, what rubbish, bogus. It associated gravity with your relationship to the ground beneath your feet. See, I believe. I'm on the ground, therefore I'm not flying into space, so gravity. Circular reasoning, ever heard of it? The assumption that they do, that we all do, is undeniable. Unless you think hard about gravity, your brain does, okay, beneath your feet, you don't have to think about gravity because you don't know it's because what? You don't have to think about gravity because you know it is in your bones. No, sorry, I don't have to think about it because it doesn't exist. But if you do think about it, you can begin to realize that what you know is in fact a series of illusions. These misunderstandings make the universe more navigable, physically and psychologically, and also leave it less mysterious. Ooh. Gravity is mysterious, remember? Consider the assumptions underlying that common answer. Gravity is the force of attraction that makes things fall straight down. Well, yes, depending on what you mean by force. We can say gravitation is one of the 4 fundamental forces. But it's such an outlier that the word force becomes nearly meaningless. The strong nuclear force which keeps atomic nuclei intact is about 100 times stronger than the electromagnetic force. Which creates the light spectrum, which in turn is up to 10,000 times stronger than the weak nuclear force which facilitates the subatomic interaction responsible for the radioactive decay. 3 forces were all within 6 orders of magnitude, one for another. Then comes gravitation. It's all about 1,000,000 billion times weaker than the weak nuclei. That's quite weak, don't you think? To put that discrepancy in perspective, you can try this experiment at home. Place a paperclip on a tabletop. There it remains, unmoving, anchored to its spot by its gravitational interaction with the entire planet beneath it. No, that is again just your belief, and you're begging the question and affirming the consequence. Wow. And having a circular argument, because you say you've put it down there, it's not moving, therefore gravity exists. It's called circular reasoning. It's not. It's the paperclip is denser than the air around it. The table is supporting it because it's sitting on something physical. That's all it is. But okay, the Earth's mass is 6.5.3 tons. A paperclip mass is 4/100th of an ounce. Now take a refrigerator magnet and wound it up over the paperclip. Presto! You have counteracted the gravitational force of the entire Earth with a wave of your hand. So I can lift things up. I'm stronger than gravity. No, mate, you're not stronger than gravity, because gravity doesn't exist. Even more unearthing is physicists that the gravitation is only force that doesn't have a quantum solution. A theory that explains the force in terms of subatomic particles. The strong nuclear has quantum chromodynamics, electromagnetism has quantum electrodynamics, the weak nuclear has quantum flavor dynamics, flavor dynamics, what a name. Gravitation has quantum Bubkis dynamics. The discovery of gravitation, a hypothetical particle that would mediate the nature of gravity's behalf in the same way to the gluon does for a strong nuclear. The photon does for electromagnetism, and the W and Z bosons for the weak nuclear. Would help, but if it exists, it has escaped detection with a cunning unparalleled in quantum experiments. Yes, quantum mechanics debunks gravity, guys. So let's strike force from our answer. In that case, gravity is the attraction that makes things fall straight down. While yes, depending on what we mean by attraction, 2 bodies of mass don't actually exert some mysterious tugging on each other. Hence, Cavendish, which you guys claim, it doesn't actually do that. Newton himself tried to avoid the word attraction for the very reason. All he was trying to do was find the math to describe the motions both down here on Earth and up there among the planets. Seen trying to describe things based on a belief. Anyway, of which Earth, thanks to Copernicus and Kepler and Galileo, was one. Yeah, the Copernicus model. Still, he was powerless as a paperclip once the idea of attraction at a distance electrified the public. Ooh. So gravitation is what makes things fall straight down. Well, yes, no, that's not true, but okay. Depending on what you mean by straight down, the path seems straight only because you're standing still relative to the Earth. No, I'm standing still because I'm standing still. I'm sitting on a chair which is firmly planted on the ground, which is not moving. If you believe it's moving, it's you having a belief again, and you should go see a consultant or doctor for that, because there might be something wrong. As Galileo realized, if you drop a rock from the mast of a ship traveling on a river, its trajectory will appear to be at an angle to an observer on the shore, similar to someone outside the Earth who is observing a rock falling on a spinning planet. The path would appear to be at an angle, but the Earth is also orbiting the Sun, so that angle would actually be swooping, creating the appearance of a curve. So in other words, Coriolis. Okay, and because the Sun is orbiting the center of the galaxy, that curve would be a very long curve. And the galaxy is moving towards another galaxy, and the universe is expanding and expanding and accelerating. How long and curlicue the rock's trajectory appears depending on wholly and where you are. And all this based on something that is not even a force. How do you get this working if there's no such thing as a force? Well, yes, depending on what you mean by fall, we can just easily argue that Einstein did expanding on Galileo's ship's shoreline relativism, that the rock isn't falling towards the Earth, but the Earth is rising towards the rock. Can I really... I have to point out what is wrong with this. This is based on Einstein, guys. Shapes. This is the Earth. Remember, it says the Earth is rising to catch everything. Which direction is Earth rising again? In every direction. Would that mean the Earth should be expanding in every direction? Is it expanding because it's rising all the time? Because is it literally changing its size now? Because that's what this means. Depending on what it means by gravity, what centimeter nothing may predict, might depend on what happens to black. Okay, now where are we? Oh, there we. But the Earth is rising towards the rock, so that means if Tom is standing here, the Earth is rising there. Harry is standing there, the Earth is rising there. If Mike is standing there, the Earth is rising there. So that means the Earth is supposed to be expanding constantly because it's rising up. Do we see this happen? No. So that already debunks Einstein if you just use normal logic. Well, yes, depending on what you mean by is, we know what gravity does in the sense that we can mathematically measure and predict its effects. Maths is not reality. We might anticipate what happens to two black holes collide or when they let go of a rock, but we don't know how it does and what it does. We know what its effects are, and we can give the name gravity to the cause of those effects, but we don't know what the cause of that cause is. If you don't know what the cause is, you don't know what it is. It means you just have a belief. You don't have science, and as far as we know, gravity is supposed to be scientifically validated. So this paper shows it's all pseudoscientific. Thank you very much. Well, obviously we don't have to read the whole paper because he's saying the same thing the whole time. Okay, it's almost finished, so we can. Not that cosmologists particularly care. Of course they don't care because it goes against their religion. In science, knowing what you don't know is a good start. No, in science, knowing what you think causes the effect is a good start. You observe something, you think there's a cause for that effect, so therefore I think this is the cause. You go make a hypothesis, this is the cause, you test it out, you make predictions on that test, and then you can go further from that. If there's no cause, you don't know anything, then it's not science. So yeah, this is just them putting a blind eye to them having a belief of it. So perhaps the key to understanding the universe is the most fundamental level. Until they will, they will work with what they do know, no matter what every bone in their bodies tells them. Gravity is not a force of attraction that makes things fall straight down. I agree, because gravity doesn't exist. It's the same as saying, thanks to what's the name? You can think of gravity as a force, but not really on the really is level. I wish I had that thing with me right now, but yeah. George Massa. It's just from George Massa. Wow, guys, I think this from the Washington Post is very telling, that gravity is just not real. It's all just belief, and not knowing what it is definitely not science. Just pseudoscience, guys.